So we're going to finish off the P chapter with the complex fraction. And we've got two methods here to simplifying a complex fraction. Method number one, we're going to go with the micro. And micro is when we first simplify the top, then simplify the bottom, then do the division. So let's do it this first way, and then I'll show you a different way, and you can pick your poison. So first of all, if we have y over x minus x over y, our common denominator is simply xy, which makes this guy missing a y, this guy missing an x. So now we've got y squared minus x squared. Over to the bottom, we have x plus y over xy plus 1. Now, one thing we can do here is remember that that is 1 over 1. So we have a common denominator of xy also on the bottom. And this little guy is missing an xy. So now we've got x plus y plus xy. So there's the top, there's the bottom, and there's the division. So this is the quantity on the top, this is the quantity on the bottom. So we're going to change it to our old-fashioned division sign. So y squared minus x squared over xy divided by, and no like terms there, so x plus y plus xy divided by xy. And recall, division by a fraction is the same as multiplication by the reciprocal. So y squared minus x squared over xy times xy over x plus y plus xy. And now we can see that the xy cancels. And pretty much that's always going to happen. When we have the denominators the same on the top and bottom of a complex fraction, they're just going to cancel. That'll make your life a whole lot easier in the future. So our answer is, simplified answer, y squared minus x squared over x plus y plus xy. So that's kind of like a piece-by-piece approach to simplifying. I call that the micro approach. Now let's look at the macro approach. And a macro is a more global approach where we're going to look at the entire complex fraction as a whole. We're going to observe every single denominator all at once and say, okay, what is the common denominator? Now, hopefully, everybody realizes that this is the DOTS right down here, and its factors are the two denominators that we see in the numerator of the complex fraction. So the macro approach says this: what if we find the common denominator for the whole problem, every single part, and we multiply using a unit multiplier, the identity. Remember, a unit multiplier is equal to 1. And what if we multiply top and bottom by that common denominator over itself? Remember, this guy is equal to 1. So what's going to happen here? We're going to use the distributive property. So all of that is going to get multiplied to this first fraction. So think about it. This is 3 over x minus 2 times x minus 2 times x plus 2. These x minus 2's will cancel, leaving us with 3 times x plus 2. Basically, multiplying by this common denominator is eliminating both of those fractions completely. Minus 4 times what? Well, x plus 2 is going to cancel with x plus 2 and leave 4 times x minus 2. 4 times x minus 2. Goodbye fractions, and now we're moving to the denominator. I'll cover all that up with a card. Of course, 7 over x squared minus 4 being x minus 2 times x plus 2, both of those are going to cancel, simply leaving 7. So now we just need to distribute and combine like terms. 3x plus 6 minus 4x plus 8 all over 7, which is 3x minus 4x is negative x plus 14 over 7. Now, one last thing. Absolutely, positively resist the urge to cancel the 7 and the 14. Anybody know why? Because of the FFCC rule. If you cannot factor, you cannot cancel. Negative x plus 14 cannot be factored, therefore nothing is going to be canceled. So this is our simplified result. Now on the previous problems we had multiple variables, so we would not be worried about a domain restriction. But in this one, everything's in terms of x. So our domain would have some restrictions here, and those restrictions would be plus or minus 2. So domain restrictions, simplified result, that is simplifying complex fractions.